So what do you see here? You probably see a white triangle pointed up, the frame of a triangle pointed down, maybe some blue circles that are covered partially by the triangles at the apex. But actually there's no triangle there, of course. It's an optical illusion. An optical illusion is formed by the fact that you've seen many triangles, thousands of triangles in your life, and you have formed a pattern of seeing triangles when you see an image like that. It's kind of the basis of optical illusions. Well, what we find is that this also has implications for innovation, and that with innovation, perspective matters. Let's talk just a little bit about what happens here and how that's formed and why it's important. So when you see the world around you, you see that in the eye, it goes down the optic nerve, ends up in the back of the head in the visual cortex. And actually, images are formed, patterns are formed, and those patterns then limit, in fact, the amount of information that goes to the frontal lobe for processing. The 40-watt device of the brain can't process everything in the frontal lobe, so therefore, for our speed and power requirements of the brain, we're actually kept safe in a complex world by having these patterns formed. The problem is, of course, that those patterns limit your ability to, as I think the term, think out of the box. It limits our ability to think out of the box because we tend to see the patterns that we've seen before. So with innovation, what we find is interdisciplinary teams, bringing people in who don't have those patterns formed, who have different patterns, is actually a big tool for innovation. And I'll just give you two examples, and I'm sure most of you in the room have seen the first one, maybe not the second one. The first one, of course, is light traveling through a couple of lenses here, an object plane, an image plane, and something called a Fourier plane. So when you think about innovation, you can imagine 70 or 80 years ago, talking to someone who was doing lens design or optics design, said, what kind of innovation can we bring you? Right, well, gee, I'm using a light table, so maybe a little different kind of light, calculating the indices of refraction, maybe a better way of doing that, maybe a better straight edge to calculate the pathway of the light. It's highly unlikely, though, that the person would have said, gee, that looks like a Fourier transform process. It was someone who had a very different background, rather than optics, who looked at this problem, and the field of Fourier optics was born. The person below there, of course, is Albert Einstein. Recent research indicates that, kind of fascinating, that Albert Einstein's brain was studied, tried to find physical differences in the brain to try to understand his brilliance. And in fact, there are indications of some differences, physical differences in the brain. Those physical differences, however, are in fact highlighted by some social science research that's being done today that indicates, based on other parameters, indications in Einstein's childhood and education, that he had a problem with understanding temporality. The concept of yesterday, today, and tomorrow, which by the time you're 4 or 5 years old is pretty ingrained, wasn't something that came natural to him. That, combined with some of the differences in the physical structure of his brain, led him to, because of that lack of understanding, approach time and understand time in a very different way. So because he didn't have some of the limitations of those filters, yesterday, today, and tomorrow, he was able to actually look at time and apply mathematics to the problem and look at the world a little bit differently. So when we think about these three programs, as I mentioned, we also think about the workforce structure that we need to put in place to support programs like this. The workforce structure inside our corporation is really not much different than it is inside similar corporations, and it's in fact largely based on a university department structure. And those are those disciplines in the upper left-hand corner, kind of identified by that red star. What we see, however, is the need to bring in those other disciplines, the gold letters on the outside. I think it gives us a huge opportunity to look at these problems differently, to think about the interdisciplinary research, and enable us to really look at a new workforce structure. And I think one of the power one of the powerful things that MIT is doing is conducting interdisciplinary research at the undergraduate level. Other universities are doing that as well. But we see that in the graduates. As people begin to understand how complex problems are solved that tend not to be single discipline problems. I mentioned that I was going to talk about innovation and that we had a couple of new areas of focus. So most of the strategic technology threads, you can think of those as developing discriminating technologies, sometimes disruptive, sometimes not, for the sake of advancing programs, getting into new areas, new weapon systems. Right. I'm going to introduce two new areas. Here's the first, and we'll call that innovation for relevance. These next two areas are really motivated by the world that we see today. As I mentioned, it's actually been 20 years ago, right, that the Berlin Wall fell. And so as we think about a 7-year war that we've been involved in Iraq, and we look at Afghanistan, we hear Secretary Gates, the Secretary of Defense, talk about focus on today's problems. Relevance is a key issue. So we've been looking at this problem. What we find is that if you think about, on the abscissa here, kind of a spectrum of warfare, where on one end you have all-out war, and on the other end, think of that as more of the peacekeeping side. Well, notionally, what we planned for up until 20 years ago, and then after that, was something that looked like that. Most of the activities were in some kind of major regional conflict, pretty heavy activities. So what does it look like today? Well, you might think that the curve looks like that, only a mirror image with it focused mainly on the right-hand side. Well, the reality is that we find ourselves in what's called a three-block war. And that is when activities are going on inside Iraq, to some degree in Afghanistan, you can have humanitarian assistance on one block, and peacekeeping going on another block, and all-out conflict going on another block. It's a very complicated, complex situation. So when we think about this area in the middle, this area in the middle is very important because it's an area where systems that were designed and built for a conventional war problem actually have tremendous applicability to the problems today. The next thing I'm going to talk about is affordability. I think it's no secret to anyone in the room that the perfect storm of the global economic situation, long time war going on in Iraq, other economic factors in the United States, the federal government is going to come under some budgetary pressure. It's unlikely that as a nation and even as a world that we're going to see a lot of new systems that are developed specifically to solve that irregular operations problem. There'll be some, but many of them will have to be current systems that are modified to do the problem. Well, the good news is that there is in fact a tremendous overlap between those two activities, and it's shown there as that shaded area. And so we think that innovation, thinking about conducting the mission, thinking about the problem for relevance, has tremendous application in enabling current systems to perform both of those missions. When we think about affordability, performance is a function of cost. And for many years, in fact many decades, we tended to live up in the upper right-hand corner. It's not to say it was things at any cost. It was to say, as I indicated before, we had a pretty slowly changing environment, and we were outnumbered. So how do you make up for that numerical disadvantage? Oftentimes use technology. So we had time to think about developing exquisite technologies that did perform very well, more expensive, and a procurement cycle that was quite long. Well, that's not where we are today. Where we are today is an enemy that changes very quickly, a different kind of environment, something in the field fast that works at the 80% level might be more important than something that gets there too late at the 100% level. And I think, as engineers and scientists, this is a bit of a paradigm change. You know, 8 dB is better than 6 dB because it is. I don't know, I think we've all been trained to think about exquisite performance. All right, so when you think about innovation for affordability, you're going to reduce the cost. Well, I think the natural state of affairs is that you come down that blue curve and you end up losing more performance up front. Some of the secret sauce goes away, and you have to work very hard to move that curve back. And so developing different concepts of operations, maybe tactics, techniques, and procedures, get you back a little bit to this y equals x curve where you're not giving up more than you're gaining by reducing the costs. But of course, that's not where we need to go. That's not where the customers need to go. That's not where we need to go as a nation. Where we need to go is over to the left like that, where you're holding performance as long as you possibly can, and then ultimately, coming down a curve that looks like that. Well, of course, that looks a lot like a systems engineering curve. And so in addition to innovation for affordability, there is also engineering for affordability. So if someone says, I want an 80% solution, that really doesn't mean an 80% solution. What it really means is I want the best possible performance at an affordable cost in time to make a difference. And if you think about critical performance parameters, and if you can't meet all of the critical performance parameters, you might actually have to change performance to think about mission. And instead of measuring it in terms of dB, you measure it in terms of mission success. And so that brings in opportunities for innovation. It also brings in opportunities for exquisite systems engineering to replace the exquisite performance.